Hello, good morning, good afternoon, and good evening. My name is Avnish, and I'm with Azure MySQL Engineering. And today I have with me Sai Kondapalli. We will focus on deployment options to provision Azure database for MySQL in Azure. Azure database for MySQL has two deployment options: single server, which has a built-in high availability, and it was GA'd almost 4 years ago. And last year, based on the feedback we have received from the customer, we GA'd flexible server, which gives you more control to optimize the cost and high availability. In flexible server, we introduced several new features, including custom maintenance window, which you can use to pick an hour window any day of the week or any day of the month. And we use this window to do the monthly maintenance on your MySQL instances. And with custom maintenance window, you have two options for maintenance windows. One is custom schedule, as I mentioned, and second is system schedule maintenance window. And we maintain 7 days gap between custom schedule and system schedule. So if you have an application where you have multiple environments, production, development, testing, and so forth, you can use custom schedule for the production instance and system schedule for the non-production instances. So we always start maintenance on the instances which have system schedule, which will give you 7 days windows to test your application and make sure there is no negative impact, whether it's the performance or functionality. Because as part of these maintenance, we also do the patching of these MySQL instances. And if you notice any differences, then you can work with Microsoft support to resolve those issues before we apply the maintenance on your production instance. In flexible server, we also provide an option to deploy flexible server in VNet, which will give you an option to deploy flexible server within the private VNet, and all your application traffic is staged within that network. We also provide a lot of configuration parameters which you can use to fine-tune your database instance. And with flexible server, you have an option to configure high availability either in the same zone or across the zones. Within same zone, you won't have the protection against the zone failure, but you will have the better application performance because of the minimum network latency. But with the zone redundant high availability, if there is an outage within the zone, then it will protect you from that outage. And we do auto failover. So if there is an outage, then we will automatically failover to the standby instance without any data loss. Lastly, simplify developer experience. We want to make sure that you as a developer continue to have the best experience in Azure database for MySQL. And with guided developer experience, you will have increased productivity and simplified end-to-end development. Because we use community edition of MySQL, it gives you full compatibility and you can leverage the same tools you have been using in your on-premise environment. And finally, stop and start and burstable capabilities gives you further advantage to optimize the cost of your MySQL instances and reduce the total cost of ownership. As I mentioned, in Azure database for MySQL flexible server, you have two options to configure high availability. One is the same zone, so you have both primary and the standby deployed in the same zone. No protection against the zone outage, but it will give you much better application performance. Second is the zone redundant high availability. In this case, your primary instance would be in zone 1 and standby instance in zone 2. And you as a customer can specify the zone both for the primary as well as for the standby instance. And with this, you can ensure both your application and database instances are deployed in the same zone to have the minimum network latency. And we also have the auto backups where we provide up to 35 days backup retention, and all your backups would be encrypted by default using AES 256-bit encryption. And depending on the configuration you use to provision these instances, we offer different uptime SLAs. So if you provision non-HA instance, then you would have 99.9% uptime SLA. If it's the same zone high availability, then we offer 99.95% uptime SLA. And if you provision zone redundant high availability, then you would have 99.99% uptime SLA. Now to provision Azure database for MySQL using infrastructure as code, there are multiple options within Azure. You have CLI, which is a set of commands to manage Azure resources. It's available on Windows, Mac OS, and Linux operating system. And it's also available on Docker container and Azure Cloud Shell. The second option is Azure PowerShell. It's a set of commandlets for managing Azure resources directly from the PowerShell. And these commandlets include both performing control and data plane operations in Azure. And based on the .NET standard and PowerShell 7.06 or 7.1.3 or higher, it's available both on Windows, Mac OS, and Linux operating systems as well. The third option is Azure Resource Manager, which is a management layer to deploy and manage Azure resources. It defines the dependencies between resources and redeploy your resources throughout the development lifecycle. You can also apply the tags to logically organize all the resources in your subscription, which can be very useful for the billing region. So if you're provisioning resources where you have the chargeback requirement to different business units, you can apply these tags to identify which resources belongs to which business unit. And finally, we have Azure Bicep, which is a revised version of Azure Resource Manager. It's a domain-specific language to deploy Azure resources using declarative syntax. And Bicep has an extension within Visual Studio Code to provide rich type safety, IntelliSense, and syntax validation. So you can use either of these options if you are using Azure as the only cloud provider. But if you have multi-cloud strategy, then you may prefer to use cloud agnostic infrastructure as code option. And that's where solutions like Terraform from HashiCorp might be a consideration for you. You can use Terraform to build, change, and version infrastructure safely and efficiently. You can use Terraform to create or manage resources on different cloud providers, whether it's AWS, GCP, or Microsoft Azure. Now, if you're using the options we discussed from Microsoft, then you would have the consistent management layer, regardless of whether you use Portal, PowerShell, CLI, or REST API commands. Everything goes through the Azure Resource Manager to manage these resources. Now, rest of the presentation will be focused on the Bicep and Terraform. And we have demonstration both for Bicep as well as Terraform to provision different resources. So what is Bicep? As I mentioned, it's a domain-specific language and it's declarative to provision or manage resources within Azure. The core functionality between Azure Bicep and Azure Resource Manager templates remain same. It has the same runtime experience, and Azure Resource Manager orchestrates the deployment of interdependent resources so they are created in the correct order. And whenever it's possible, it tries to provision resources in parallel to speed up the deployment and provide you a much better experience. And the latest version of CLI and PowerShell have built-in capabilities or support for Bicep. So from the Azure CLI, you can use this syntax AG deployment, group create, you specify the Bicep file and the group name, resource group where you want to provision all the resources. And I will demonstrate this in my demo in next few minutes. So the workflow for provisioning resources using Bicep goes through the four different phases. First is the authoring. So you will author the provisioning of different resources using Bicep. Then it goes through the validation to make sure that all the dependency, syntax, and everything is correct. Then finally, deployment of those resources and the management later on. So during the management phase, uh, you will be provisioning resources. You might be updating or deleting those resources. So it has four different phases: author, validate, deploy, and manage. Now the format of Bicep is different than Azure, Azure Resource Manager. Bicep is more easy to read and easy to write because it doesn't have any unnecessary JSON noise. Um, so it's very easy and compressed than the JSON format we have seen in the Azure Resource Manager templates. And because it's a first party language, you would have day zero support for all Azure resources, whether it's a introduction of the new service or new features we introduce in the existing service. You will have Bicep support day zero. Um, it's a extremely modularized language, so you can have different modules. You can call these modules within each other. So it gives you further code reusability for these different resource provisioning. You can specify the commands using the slash slash or slash star if you are doing multi-line commands. And finally, using this output, you can verify the state or query the state of the resources provisioned within the Azure. So on the right hand side, you specify the scope, then you can specify the different parameters, variables, and the resources you are provisioning. And if you're using modules, you can call these modules. And finally, the output. And I have different Bicep files to demonstrate all those things I mentioned here. With that, I'm going to switch to demo of the Bicep. And during this demonstration, I will use Bicep to provision Azure database for MySQL single server and flexible server, which will be deployed in a VNet. And because of that, we will also use Bicep to provision VNet a dedicated subnet, and a DNS. And finally, just to demonstrate bicep capabilities further to provision other resources, we will provision app service and Azure storage. And there are a couple of links I have included here to give you jump start if you plan to use bicep to provision Azure resources. So as I mentioned that I will use these in this demonstration, I will use bicep to provision multiple resources, including Azure database for MySQL, single server, and flexible server. And for flexible server, which is deployed in the VNet, I will use bicep to provision VNet, a dedicated subnet, and a DNS. And finally, I will use bicep to provision app service, which you can use to deploy your application. And I'm also provisioning Azure storage. So what I have is a command prompt, and I already connected to my Azure subscription, and I will be using these files to provision resources I mentioned few seconds ago. So I have main.bicep, which I'm using to provision VNet, subnet, and a flexible server instance within that subnet, Azure storage, and I'm calling a module to provision app service. And then I have this standalone bicep file to provision single server. And within this module, I have this app service bicep to provision app service. So this is the resource group I'm going to use, DPS 2022 RG. And as you can see, I don't have any resources right now. So let's launch this bicep file, and I will walk through all the three bicep files I put together to provision resources. So it's going to take a couple of seconds to start provisioning those resources. So in the meantime, I'm going to open these bicep files. Let me specify the password for the which I'm using for the flexible server instance. So it's running now. So this is the main.bicep file, which I just called from the Azure command line. So in the beginning, what I have is a bunch of parameters and variables I declared. So first variable is the location. So it's the region where my resources would be provisioned. And I'm using this resource group routine to grab the location information. Then this is my VNet parameter, and this is my default value. Because it's a parameter, you can specify and change the value from the command prompt, as I did for the environment type. So in this case, environment is defined as non-production, and I will show you in a second in the bicep file. I'm also specifying the VNet address range, both for the VNet as well as for the subnet. And this is my DNS for the flexible server. This is the default instance name. Again, this is a parameter, so if you prefer, you can change this from the command prompt. And then I'm specifying the allowed values for the compute tier in Azure database for MySQL. So we support general purpose, memory optimized or business critical and bustable. So in the parameter, it will accept only one of those three values and default is bustable. This is my login name or admin name for flexible server. And then this is the parameter for the password. So if you notice, I'm specifying that minimum length for the password is 8 and it should be secure. So if you notice when I type the password, nothing did show up on the screen. Um, I'm specifying the storage allocation 20 GB IOPS, so 360 IOPS. MySQL version allowed values are 5.7 and 8.0.21 and default is 8.21. The backup retention is 7 days and then geo backups are disabled. So it will take all those values during the provisioning of flexible server instance. So it's going well so far. And if you do come here and refresh, you can see that resources are already start provisioning. So we already have the VNet, DNS has been provisioned successfully as well, including the app service storage account and app service plan. So it's waiting for the flexible server right now. So this is the more to provision the VNet. So I specify this API call and then the VNet name, location, and other properties. And then I'm provisioning this subnet. So this is the syntax to indicate that this is a dedicated subnet for Azure database for MySQL flexible server. And then here I'm provisioning the DNS. And finally creating the VNet link for the flexible server. And this is the resource for provisioning the storage account. So you specify the storage account name. Again, this is one of the parameter. And you specify the storage v2 type and access tier. We support hot, cold, and archive. So you can specify the access tier for the storage account. And here I'm calling the module which I'm using to provision the app service. So you specify the module name and the parameters which you are passing in this module. So in this case, I have location, app service name, and the environment type, which I specified from the command prompt. And this is the resource I specify to provision the flexible server. So this is the server name, which is a parameter, and then location, SKU type, SKU tier, and other properties like storage is autogrow enabled, IOPS, which is a parameter I specified in the beginning of the file, storage allocation is GB, create mode by default, it's default if you're provisioning read replica, then create mode would be different. Then MySQL version, backup information, like how long you want to retain these backups, and whether you want to have the geo backups with geo redundancy or not. So with geo redundancy, we will copy your backups from primary region to the paired region, which is a great option to protect you against the regional outage. Another option is to provision the read replica. So in that case, you would have the read replica with async replication in the region you specify during the provisioning of the read replica. So there are two options to protect you against the regional outage. One is this geo backups and second is the read replica. You specify the high availability. So in this case, I specified disabled, but you can specify whether the same zone or zone redundant high availability. And finally, the networking information, the subnet ID and the DNS zone ID. And I'm using this output parameter to um, to query the app service information. So it's still running. So this one is completed. And now let's provision the single server. So I'm calling this DPS 2022 single.bicep.
In the last few minutes, Avnish has provided an overview on deploying your resources through various options such as CLI, PowerShell, Azure Resource Manager, and also walk you through demo of Bicep. Now we are going to spend some time looking into what Terraform is and how Terraform is helping customers deploy their resources on Azure. So first, diving deep into various intricacies of Terraform, let us first understand what Terraform is, right? So Terraform is an open source or a third-party software infrastructure as a code tool. It lets you define resources and infrastructure in human-readable declarative configuration files and manages your infrastructure's lifecycle from provisioning resources to updating your resources and also destroying resources. Using Terraform, you have several advantages over manually managing your infrastructure, such as you can use these Terraform templates to manage infrastructure on multiple cloud platforms, and Terraform can also help track resource changes throughout your deployments. And Terraform plugins called providers define individual units of infrastructure for you in your cloud. For example, compute instances or deploying private networks or deploying Azure database for MySQL service, which is a database service, as your resources at the end of the day. And you can compose resources from different providers into reusable Terraform configurations called modules and manage them with a consistent language and workflow. So providers let Terraform interact with these cloud platforms and other services via their APIs. Providers are written to interact with Azure, AWS, GCP, Kubernetes, GitHub, Splunk, to name a few. And the way Terraform is written is in a format called HashiCorp configuration language, and it automatically can identify any dependencies between resources that you are either creating or updating. For example, let's say that you are trying to deploy an Azure database for MySQL server in a private network configuration. Of course, it is dependent on a couple of other network topology configurations prior to deploying your database service. For example, such as having your virtual networks deployed firsthand, and secondly, you also need to have your subnets where your Azure database for MySQL service sits, and also you need to establish your private links, etc., for your database service to be appropriately defined and deployed in your resource groups in that private network topology configuration. So Terraform can track all of those dependencies and ensure that your resource is being deployed properly. So Terraform is a standard interface where you can provide inputs for the resources that you are defining and deploying, and it can also return outputs. For example, let's say that you are trying to deploy a database server of compute capacity 32 core. Obviously, that is an input that you are defining for your database. Similarly, other characteristics such as your storage sizes, etc. And once the deployment is complete, it can also perform other things such as returning outputs for your deployment configuration, such as fetching the fully qualified domain name of the database server that has been deployed, so that you can use that FQDN to integrate with your application, or even with other Azure services such as app services, etc. Right? So it can provide all of these simple inputs and output definitions where you can give in the values and also get the values of the deployed resources. And we'll in the next slides, we're also going to look at Terraform modules, but to provide a brief overview here, what it means is that you can kind of containerize your deployment so that they are easier for you to manage as well as reusable, so that you can deploy your infrastructure in multiple environments using the same topology configurations. Let us now look at how Terraform works. So basically for Terraform, for Terraform templates, you define what infrastructure services and resources you're going to deploy for your application, and write that in the HashiCorp configuration language. So that's how the template is defined, and the template contains the resources that you're trying to deploy. And for example, let's say that you are trying to deploy an application where the application is dependent on multiple resources, such as your virtual machines that are more or less hosting your application, and as well as your virtual network in which the VMs are going to reside. And that is how you're going to define the isolation of resources using virtual networks, the subnets under the virtual networks, and defining the appropriate security groups, and a load balancer to obviously load the client request hitting the application running on the virtual machines. And in the backend you can have your database services, etc., right? So once you define all of this in a Terraform template, the next step is that to ensure that everything is going to execute and the infrastructure is going to get deploy as you define. So for that you are going to do something called an execution plan in Terraform, and it basically gives you all the relevant details, like how the infrastructure is going to be deployed and whether it is going to be an orderly deployment or not, like we just discussed, where some of the resources are dependent on other resources, etc., right? So to ensure that the dependencies are kind of tackled prior to the actual execution. So once everything is looking good, the next step is that you would go ahead and perform the proposed operation, which is to execute, and it will deploy the resources in the correct order, and honoring any resource dependencies. For example, the ones that we have just discussed, such as the virtual machines have to be deployed in your subnets, and the subnets are pretty much isolated using the CIDR ranges using under the virtual network. So obviously VNet has to be deployed, and after VNet the subnets, and after subnets obviously you can deploy your virtual machines. So let us look at one of the components of Terraform, which is the Terraform providers. So before diving in there, Terraform has two important components: Terraform Core and Terraform plugins. So Terraform Core is nothing but it takes into consideration the current state and evaluates it against your desired configuration. It then proposes a plan to add or remove infrastructure components as needed. Next, it takes care of provisioning or decommissioning any resources if you choose to apply the plan, which we have discussed in the previous slide. And then we have the Terraform plugins, which are called providers. They define individual units of infrastructure. For example, your compute instances or private networks or databases as resources. You can compose resources from different providers into reusable Terraform configurations called modules, and manage them with a consistent language and workflow. All providers come with Terraform registry, which makes it easy to use any provider or module. To use a provider or module from this registry, just add it to your main configuration file, which we are also going to look at when we go through the demo. And when you run Terraform in it, Terraform will automatically download everything it needs. Over here, details regarding providers such as versions, etc., are noted. And now let us look at some of the components of a Terraform template, such as your input variables, the outputs, as well as the local clock, and what each of that means. So firstly, if we are looking at input variables, they serve as parameters for Terraform modules or Terraform templates. So users can customize behavior using these input variables without editing the source. And these input variables make your infrastructure as a code Terraform template scalable and reusable, and allows you to share modules across different Terraform configurations. And coming to output values, these are like return values for a Terraform module and make information about your infrastructure available on the command line after their execution, deployment, and completion, and can expose information for other Terraform configurations that are dependent on the prior Terraform configuration so that they can use it. For example, after deploying your infrastructure, you would like to know the fully qualified domain name of your Azure database for MySQL Server, and you can define that as one of the output values. So once the database server has been deployed, it can give you the FQDN of the Azure database for MySQL Server. In coming to local values, more or less like a convenience feature for assigning a short name or an expression, so you can use the name multiple times within a module instead of repeating this expression, right? So, for example, when you are deploying the resources, you would like to deploy them with the application name as well as the owner of the resources, etc. That would prefix the name of the resources, right? So as part of your infrastructure deployment, so you can use these local values. And some other components inside a Terraform template are more or less like modules. So as you manage your infrastructure with Terraform, you will create increasingly complex configurations, right? So there is no intrinsic limit to the complexity of a single Terraform configuration file or a directory. So it is possible for you to continue writing and updating your configuration files in a single directory. However, if you keep writing everything into one single file, you may encounter one or more problems, such as understanding and navigating the configuration files will become increasingly difficult as you keep on adding resources and that is not written in modules. And updating the configuration will become more risky because now that there are like more and more resources that are dependent, it becomes complicated and may cause unintended consequences to other parts of your configuration. And there could be an amount of duplication of similar blocks of configuration if not written properly. For instance, for separating dev, staging, production environments. And you may also wish to share only parts of your configuration between projects and teams, and for them to be called appropriately from the other files. You'll quickly find that cutting and pasting blocks of configuration between projects is error prone and hard to maintain. So modules basically make it easier for you to organize configuration, encapsulate this configuration, reuse the configuration, and provide consistency and ensure best practices. So for Terraform to deploy Azure database for MySQL, there are certain resource names and what they intend to provide for each of the deployment choice. So we have Azure RM MySQL Server, which means it manages a MySQL single server, and Azure RM MySQL Database, which kind of manages the MySQL database within a single server, and any server keys such as CM keys that are to be used for your single server, and any virtual network rules such as the firewall rules, etc. And coming to flexible server, you also have similar options such as managing a MySQL flexible server using Azure RM MySQL flexible server, and to manage a database within a MySQL flexible server, you use the resource as Azure RM MySQL database. And any firewall rules for your MySQL flexible server, you would be managing through Azure RM MySQL flexible server firewall rule. With this, I'll turn it over to Avnish so he can showcase you how Terraform works through a demo.
So in this demo, we will use Terraform to provision Azure database for MySQL single server and flexible server. In addition to that, we will provision some other resources just to demonstrate more capabilities of Terraform. And as I discussed, Terraform also goes through a workflow. So you obviously start with authoring the code where you specify all the resources you are trying to manage using Terraform. And once you have all the Terraform code written, then in the working directory where you have all the Terraform files, first step is to initialize the working directory. using the Terraform init command. And once your directory is initialized, then you do Terraform plan. And during this Terraform plan phase, Terraform review all the files, validate the syntax and all those things. It also analyze the dependency and identify which resource is a new resource and which resource we are trying to scale up or scale down, and if there is any resource we are trying to destroy. So it identifies all those resource management as part of the Terraform plan. You also have an option to save this file in a plan output file. So you can specify Terraform plan dash out equal to plan file. And later, if you prefer, you can use this file when you are doing the Terraform apply. And during the Terraform apply, Terraform really goes through the Terraform plan file or Terraform plan it generated before to to manage resources you specified in the Terraform files. So it's fairly straightforward. So what we would do, I will switch it to my working directory where I have all the Terraform files. So I have already run Terraform initialization step, but I will do it again. So you can do it multiple times. And as I mentioned during the initialization operation, it downloads all the required modules. So it doesn't take, so it's already completed. And now I'm going to do Terraform plan. So it takes a couple of seconds before you see the prompt to confirm whether you want to proceed further or not. So let's give it a second. So Terraform generated the plan, and as you can see that there are multiple resources. Let me scroll up a little bit. So it generates a lot of information, and as you can see there, pretty much every single line has the plus sign because we are running this plan first time, and it will provision multiple resources uh, using the Terraform files we authored. So now let's do Terraform apply, and it will ask for the prompt to proceed further. So as you can see, it's waiting for the confirmation to proceed further. And if you look at the changes to output during this apply phase, um, it will create all these different resources. It will create the VNet, it will create the read replica, it will create resource group, all those resources. So one thing I want to highlight here that we don't the Terraform plan we are using will also create the resource group which we are using to provision the resources. So Terraform, the resource group we are provisioning is Terraform, sorry, DPS 2022-Terra-RG. So as you can see, this resource group doesn't exist right now. And so let's confirm this. And then it will take a few seconds before it start proceeding further. And when we refresh, so let's review the some of the files. So what we have here, we have multiple files. So one is this MySQL flags.tf. TF is the extension for Terraform files. So this is the file we are using to provision Terraform, sorry, flexible server instance. Then we have MySQL ss.tf. So this is to provision single server. And network.tf is to provision required network resources. So it will provision VNet, it will provision dedicated subnet and firewall and so forth. Provider is the main file in this case where we specify provider. In this case, it's Microsoft Azure. If you are using AWS, then your provider would be AWS. RG is for resource group. So we provision the resource group using this Terraform file. Then we have storage.tf to provision storage and analytics workspace. Analytics workspace is something you can use to enable the diagnostics for different services. So, and then finally variables.tf, where we specified all the different variables we are using across all these different Terraform files. So as you can see, it start provisioning different resources. So first resource it's provisioning each resource group. And as we discussed in Bicep, Terraform also had this nice feature where you don't have to specify the dependency between different resources. It automatically analyze the dependency and provision resources in a specific order. But it does provision these resources sequentially, versus as we discussed in Bicep. Bicep try to provision resources in parallel where it makes sense. So it really speed up provisioning of multiple resources using Bicep. So if you look at here, let's do the refresh. And as you can see, the resource group has already created. And these are some of the resources which have been provisioned successfully. So we have VNet, we have storage account which is provisioned, analytics workspace, the DNS which we will use to provision flexible server in a VNet. So let's review some of these files. So this is the main file as I mentioned where I specify the provider. So as I mentioned that my source in this case is Azure Resource Manager. So Azure is the provider. Then you specify the version of the Terraform you want to use, and the Terraform CLI version. And I specify the subscription ID, which is one of the variables I defined in the Terraform variable files. And this is my variables file. So here I have this resource group variable. You specify the description, the type of the variable, default value. So in this case, this is the resource group we created as you saw a few seconds ago. Then you can specify whether a given variable can have null value or not. You can also specify sensitivity of the variable. So in this case, we are saying it's false. If you say true and you type the value at the command prompt, then value won't show. You can specify the validation rules. So in this case, we are saying that the resource group must be greater than 4 and first 7 characters of the resource group should be DPS 2022. So in this case, when I did the Terraform apply, I didn't specify any of those variables. But if you apply those in the command prompt, then it will go through these validation rules. Then I have the region. So I specify the region default value South Central US. Then I also have these variables for the so this is one of the variable I'm using to specify whether I want to provision flexible server in high availability mode or non-HA. So default is null. So the flexible server which we are provisioning won't have any high availability. But you can follow these kind of rules to specify conditional parameter in Terraform. Then this is the locals. So locals is a um, group of variables which you can use. So in this case, when you use this common tags, it will automatically create all these tags owner equal to MySQL engineering, name is DPS 2022 demo, and environment. So when you apply this common tags on a given resource, it will create these tags for that particular resource. Now this is my storage Terraform file. So it's fairly straightforward. You specify the name of the storage account, resource group I'm getting from the variable name. Same is true for location, uh, account tier, nature of the storage. So in this case, it's locally redundant storage. Then you specify the networking rules. So by default, nobody would have access to the uh, to the to the storage account. You specify the IP rules, and in this case, I'm assigning this tag to this resource to this storage account. And this is the resource or the module I have for provisioning log analytics. Now let's look at the single server. So fairly straightforward. I'm specifying the name of the single server I'm provisioning, location and resource group I'm getting from the variables I defined, and then this is my login name and password. These can be parameter at the time of input, but I'm hard coding those values. I'm specifying the version and the SKU, storage allocation, backup retention, all those parameters I'm defining in this file. And then once resource group, one single server is provisioned, then I'm saying that create these firewall rules. So by default, it will have IP address range from 000 to 255. So everybody would have access to this single server instance. And then I'm creating this database. So after single server is provisioned, it will create this database DB1, and we'll review this in the portal in a second. Similarly, for flexible server, um, I specify the name and all these different parameters to provision single server. And because I'm provisioning flexible server in a VNet, I specify the subnet, the DNS which I provision in the network Terraform file, the storage by auto grow is true, and size is 20 GB, and it will have 500 IOPS. You can also specify the maintenance window. So I'm saying that Sunday 10 o'clock or 10:30, um, we can do maintenance on this instance. And this is the dynamic variable for the to provision whether you want to have the high availability or not on the flexible server we are provisioning here. You can also specify the timeouts. So for any region, if provisioning take more than 60 minutes in this case, then it will automatically time out, rather keep on trying. So these are some of the options you can specify in Terraform. Then you have the environment tagging, and then dependency. As I mentioned, the Terraform automatically identify the dependency, but just for the example, I'm specifying the dependency here. And then these are the firewall rules. It's not required because I'm provisioning in the VNet, but and then I provision the database like I did for the single server, and finally a read replica. So in this Terraform file, we are also provisioning a read replica for this flexible server. So I'm saying that before you read replica provisioning cannot proceed until we have this flexible server provision successfully. And then you have the name of the read replica, resource group, location, and so forth, timeout information, and that's all. So let's see how we are proceeding with that. So it's still provisioning those resources. Let's give it a second. So as you can see, it's still provisioning different resources. Currently, it's provisioning read replica. And if you look into the portal, You can see majority of the resources are provisioned successfully. We're just waiting for the read replica. So let's look at this single server. So as you can see, this is the server name we specified, the login name, the version of the MySQL instance, and the server configuration. But if you look into the connection security, you will see the firewall rules. So this is the firewall rules we specified in the Terraform file. And let's look at the flexible server quickly. So again, some basic information. And as I mentioned that we also provisioned a database. So you can see FlexDB1 was created successfully, and still provisioning the read replica. But read replica, once it's provisioned successfully, will show up here. So read replica is also provisioned successfully. You can see the time it took to provision read replica. So in this case, it took 9 minutes. And this is the final output from the Terraform after provisioning all the resources. So if you come back to the portal, if you do a refresh here, you can see this read replica which we provisioned using Terraform. So provisioning resources using Terraform is fairly straightforward, and it's a but often we hear from the customers asking this question, what they should use, Terraform or Bicep, because Bicep is the revised version of ARM templates. So what we recommend customers that if they're if they are moving towards multi-cloud strategy or already using multiple clouds, then it might make sense to use Terraform, because Terraform, as we discussed, it's cloud agnostic. So you don't have to maintain two different skill sets or two different um, these different resources to manage these resources you are provisioning between different clouds. But if you are using only Azure cloud, then it might make sense to use Bicep, because one of the key advantage with Bicep is that you will have access to all the resources, all the new features day zero. So whenever we release a new feature or new service, you will have support for that. Versus on Terraform, it may take 3 months or so before you can leverage Terraform to provision these resources. So with that, we really want to thank you for taking the time. I hope you find this session helpful, and bye.